Hi everyone, welcome you all to the brilliant group of institution. Hope you all are preparing well for your upcoming term 1 examination. In this session, I'm going to discuss the CBSE Grade 12, some of the most important question including one of the sample paper for chemistry. Okay, in your term 1 examination, totally have 3 sessions for your examination. Section A, Section B, Section C. So let us directly go to Section A. So in Section A, totally have 25 questions. We can start from question number 1. Question number 1, affinity for hydrogen decreases in the group from fluorine to iodine. Which of the halogen acid should have highest bond dissociation enthalpy? This question is a familiar question you may studied in haloalkane chapter, P block element, right? Hydrogen halides. What are the hydrogen halides? We have the halides are fluorine, chlorine, bromine and iodine. Their hydrogens means the hydrides mean HF, HCl, HBr, HI. Which bond is stronger, which bond is weaker, right? HF, fluorine is the most electronegative element in this group, halogen family. So fluorine with the hydrogen is a very strong bond, all right? So this is a very strong bond. When you're coming down the group, the size of the halogen increases. As the size of the halogen increases, the bond get weak, right? This is the weakest bond. Alright, so the question, which of the halogen acid should have highest bond dissociation enthalpy? What is bond dissociation enthalpy? Amount of energy required to break the bond. Alright, so which is the strongest bond? HF bond is the strongest one. It requires maximum amount of energy to break the bond. So what is that? Maximum highest bond dissociation enthalpy is for HF greater and least is for HI. Alright, question number 2. Simple question from DNA, RNA, that is the chapter biomolecules, right? DNA and RNA contain 4 bases. Very well, DNA contain the bases which all are there? A, T, G, C, right? Adenine, thymine, guanine, cytosine. Whereas RNA which contain A, U, G, C, adenine, uracil, guanine and cytosine. So in DNA there is thymine, instead of that RNA contain uracil. That's the only difference in nitrogen base. So which of the following base is not present in RNA? What is that? Thymine. That's only in DNA. So the answer is what? Option C. Alright. Question number 3. The bleaching action of chlorine is due to, chapter is which one? P block element, group 70. Bleaching action of chlorine. Dear student, chlorine water, right? Cl2 water. We studied that chlorine water on standing, right? Chlorine water on standing means when you keep a chlorine water in a test tube for a long time, you can see that it's producing very important 2 gas that are acids are HCl and HOCl. What is meant by HCl? Hydrochloric acid. HOCl, hypochlorous acid, right? And here, this HOCl, the produced HOCl decompose, it will give you HCl with a oxygen. What is this called? Nascent oxygen, right? So because of the production of nascent oxygen, it acts as a bleaching agent. So what is this process called? Oxidation or reduction or a chlorination or hydrogenation? That's what, dear student, chlorine act as a bleaching agent, that because of what? Oxidation, right? Oxidation. So it's producing oxygen, right? So keep in mind, chlorine, it act as a bleaching agent, that's due to oxidation. Sulfur dioxide, SO2, act as a bleaching agent because of what? Reduction. Okay, very important one, reduction. Chapter is which one? P block element, group 70. Question number 4. Which among the following is most reactive towards SN2 reaction? SN2 reaction, substitution nucleophilic bimolecular reaction. What is the reactivity order? We study that primary greater than, secondary greater than, tertiary. Because SN2 reaction favor in a less steric crowded system. Yes or no? The less steric, which is the system having less steric crowdiness, steric hindrance is minimum, their SN2 reaction more. Let's see the species are given. Option A is given MEX. Me stands for what? Methyl. So methyl with one halogen. Second one is given RCH2H. Let me take one R group as methyl group. So RCH2X. And the compound C is given R2. That is CH. R2 means there are two alkyl group. Any alkyl group, okay? I'm just taking two methyl group with one halogen. And D is for CH3, 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 which one? Halogen. There are three alkyl group. Okay, let me take the alkyl group is methyl group. Alright, which is the less steric crowded system, dear all? See, this is a primary haloalkane, right? The halogen connected carbon directly connected to one carbon. It's a primary haloalkane. Here halogen connected carbon directly connected to two carbon. It is a secondary haloalkane. Here halogen connected carbon directly connected to three carbon. It is a tertiary haloalkane. Alright? Yeah. What about this? It is also a primary, especially it is a methyl, just a methyl group. Where is the less steric crowdiness or less steric hindrance? That is in option A. As or no, this is tertiary reaction, tertiary haloalkane. Which reaction is favor? SN1 reaction favor. It is secondary, it's primary. This is the very less crowded, just a methyl group is there. So here the reaction can be happen so fast. Let's go with option A, will undergo SN2 reaction faster. Question number 4. Here we have, which color is observed when zinc oxide is heated? Which chapter? Solid state. In solid state chapter, the last part you're studying what are the defects, right? What are the imperfection in crystals? You're studying stoichiometric defect, non-stoichiometric defect, impurity defect, etc. In non-stoichiometric defect, you're studying again two, metal excess defect and metal deficiency defect. Metal excess defect is happen because of two reasons. One is anionic vacancy occupied by an unpaired electron. That's called which one? F sender. Second one is called metal excess defect due to the extra cation in the interstitial site. This zinc oxide belongs to that category. Which one? You study that non-stoichiometric defect. Non-stoichiometric defect. Non-stoichiometric defect, one set is called metal excess, one set is called metal deficiency. This is belongs to metal excess defect. Metal excess defect is happen because of two reasons. One is due to F center, one is due to the extra cation. The extra cation in interstitial site. Extra cation in interstitial site. It belongs to that category. You may study one of the equation or an example in this category, zinc oxide. Zinc oxide is a white colored compound crystal. When you heat it, zinc Zn converted to Zn2 plus by losing 2 electron, and the oxygen exists as what? We can write half O2. The zinc oxide is a white colored one, but when changes to Zn2 plus, you may study that it's having yellow color, right, dear student? So color is observed in zinc oxide heated mean that is because of the Zn2 plus formation. That's color is yellow in color. Which part? Solid state chapter, non-stoichiometric defect, metal excess defect due to there is an extra cation in the interstitial side. Which is the extra cation here? Zn2 plus. Alright. Next one. At a room temperature, HCl is a gas while HF is a low boiling liquid, right? At room temperature, they are saying HF is a liquid whereas HCl is a gas. Dear student, mostly a substance want to exist in their liquid state, they should have a strong hydrogen bonding, intermolecular hydrogen bonding. It's very simple. Fluorine and chlorine, that's only the difference here. Fluorine is the most electronegative element, a most electronegative element with hydrogen. That is a very strong bond. That's a very strong bond. Which bond? Very strong intermolecular hydrogen bonding. Very strong hydrogen bonding. Stronger the hydrogen bonding, it can exist in liquid state. Whereas in HCl, chlorine is the element, its electronegativity little lesser, so hydrogen bonding is not that much. So it exists as gaseous state. Alright. So if a substance want to exist in liquid state, majority the answer will be they having a greater force of hydrogen, intermolecular force of attraction between the elements, the species. Alright, so here the answer is what? At room temperature, HCl is a gas while HF is a low boiling liquid. This is because of HF bond is covalent? No. HF bond is ionic? No. HF has metallic bond? No. HF having very strong hydrogen bond. Because of that, HF is liquid, HCl is gas. Here we are going to question number 7. Which reagent will you use for the following conversion? Dear all of you, please observe. What is this compound? CH3, CH2, CH2, CH3. That is nothing but butane. To which you are adding which one? You can see here the product 1 chlorine is there on first carbon. So 1 chlorobutane. Here chlorine is on second carbon. Therefore it is called 2 chlorobutane. Dear student, a pure hydrocarbon, a alkane. How you can add a halogen? Substitution, right? Substitution, right? If you want to add 1 chlorine into butane, ethane, whatever the hydrocarbon, what is the reagent you are using? The chlorine. Which halogen is coming here? Chlorine. So add chlorine in presence of light. You know, substitution reaction takes place in presence of heat or light. Majority light. What is that? Your chlorine UV light. Chlorine with UV light. Chlorine gas in dark condition. Substitution won't happen on hydrocarbon. NaCl H2SO4, no. Chlorine in the presence of iron in dark, no. Substitution reaction takes place in presence of light. Alright, next one. Question number 8. Which solid which do not show, right? Solid, so the chapter is which one? Solid state. Solids which do not show the same physical property in different direction. Dear student, same physical property in different direction is called which one? Isotropic in nature, correct? You studied that crystalline solids are there, amorphous solids are there. Crystalline solids mean, you know that they are anisotropic and amorphous solids are isotropic. What is meant by isotropic? The physical properties of a crystal when you calculating. What are the physical property? The electrical resistance or refractive index. Then the electrical resistance or refractive index of a crystal when you calculating in different direction, if you are getting the same value, then it is called what? Isotropic. In different direction, if you are getting different value, then it is called what? Anisotropic. Correct. So same physical property in different direction is called isotropic, but do not show the same one. So what it is called? Anisotropic, right? It is called anisotropic, which means the physical properties are getting different values in different direction. That is what? Anisotropic solids. Next one. Question is from the chapter Solutions. For a binary ideal liquid solution, you know, ideal solution means they obey Raoult's law. The total vapor pressure of the solution is given. So dear all of you, you may study 2 equations to calculate total pressure of a system. Alright, P total, there is an equation P naught A plus mole fraction of B into P naught B minus P naught A. This is one of the equation to calculate the total pressure of an ideal solution. Then another term you can write P total equal to, this is I am writing in terms of A. If you can write it in the term of B, then just change all these letters. The mole fraction of B becomes mole fraction of A. The vapor pressure of the pure component B become vapor pressure of pure component A. This A becomes B. That's it. This is the equation generally we are using to get which one? The total pressure of 2 solution, especially their ideal solution. So which equation you can observe here? P total is equal to P naught A plus XB into P naught A minus P naught B. No. Option B, P total equal to P naught B plus XA into P naught A minus P naught B. Yes, option B can be. Option B can be. So carefully the letters, okay. For trying to remember this equation, just follow this method. P total is equal to, if you want the answer in terms of P naught A, okay, so P naught A plus, then you use the mole fraction of the other one. Here you already used the A, so take the mole fraction of the other component, that is B. Here you are using mole fraction of B, so nearby you take the vapor pressure of the pure component B. Then minus the opposite. Just see the apply here, same one, P naught B. This is in terms of P naught B. So you take the mole fraction of the other component. Here B, so here A. The A same you repeat here, then the opposite here. That's why. Alright, so through that they can ask you the numericals also. Okay, dear all of you, keep practicing the NCERT textbook questions. Next one. Question number 10, graphite. So I think it's related to the solid state chapter. Graphite cannot be classified as. You studied, there is a further classification of crystalline solid. Crystalline solid, again we classify into 4 systems, dear all of you. What are they? Molecular solid, ionic solid, covalent or network solid, and metallic solid. Where you studied graphite, graphite is a covalent or network solid. Correct. So it is a covalent solid, it is a network solid. Even it is a conducting solid, right? You know, studied graphite can conduct electricity. Is it a ionic solid? No, it is not an ionic solid. Only one example we studied in textbook for ionic solid. What is that? NaCl, sodium chloride. So graphite cannot be classified as which one? Option D, ionic solid. Question number 11. Bromination of toluene gives. Haloalkane related chapter question. Bromination of toluene. You know, student, what is mean by toluene? Benzene with CH3. That's called toluene. All right. Bromination. Addition of the electrophile bromine. Okay, so bromination, normally we are using bromine in presence of CS2 medium, right? Carbon disulfide. If you want strong bromination, we can use bromine water. All right. So the whatever that, it's undergo bromination. You know, bromination mean addition of the electrophile Br+. So the Br electrophile is waiting to attack either ortho, meta or para position. It is decided by the existing group on benzene ring. Which is the existing group on benzene ring? That is methyl group. You know, alkyl groups act as a ortho-para directing group. Alkyl group when present on benzene ring, they act as a ortho-para directing group. Means the bromine electrophile can goes to ortho and para. So your product will be, 2 products will get it, right? This is toluene plus toluene, 1 bromine ortho position, 1 bromine para position. Ortho bromo toluene, para bromo toluene. These are the products you are getting. So what's your answer? Answer is the right. Only meta products won't get you. And only para, no. Mixture of ortho and para substituted product, yes. Mixture of ortho and meta, no. Suppose they are asking you, which is the major product forming? Of course, para is the major product because of the greater symmetry, right? So option C is the answer for question number 11. Question number 12. At isoelectric point, chapter is which one? Biomolecule. Area, protein, amino acid, Zwitter ion, right? Zwitter ions are which one? There is an isoelectric point, right? You know, what is an amino acid general representation? Let me take RCH NH2 COOH, right? This is called a the amino acid. You know, amino acid can exist as a Zwitter ionic form. How? Here nitrogen amine part is basic in nature, COOH is acidic in nature. Nitrogen contain a lone pair. By donating this lone pair, it can abstract this hydrogen. So you will get RCH NH2 taking the hydrogen, so it become NH3. It's donated. Actually, how they are getting this hydrogen? By donating this lone pair, so it will get a positive charge, and here we have COO minus. Because from this side, hydrogen is leaving as H plus, so the oxygen carry negative charge. This is called what? Zwitter ion, right? Zwitter ion. What is a Zwitter ion? A species having both positive and negative charge. A dipolar species is called Zwitter ion. A isoelectronic point question option A. Concentration of cation is equal to concentration of anion. Yes or no? Yeah. There is an equal number. Isoelectric. Isoelectric mean there is 1 cation, there is 1 anion. Is isoelectronic. Okay. Net charge is 0. Of course, right? It's neutral one because 1 positive, 1 negative. When they are equal number, they will be cancelled. Neutral, right? Maximum concentration of dipolar ion, that is called Zwitter ion, will be present. Yes, Zwitter ion means a species contain which one? Positive and negative charge. So shall we go with option D? Yes, option D. All of these are possible for a isoelectric point. Okay, chapter is biomolecule. Next one, question number 30. Chlorobenzene can be prepared by reacting aniline with. Chapter haloalkanes and haloarenes. You may studied how to convert aniline into chlorobenzene. Let's follow the mechanism once again. You know what is called aniline. Benzene with NH2 is called aniline. Aniline you cannot directly convert it to chlorobenzene, right? First we are doing which one? Diazotization. What is diazotization? We are treating with NaNO2 and HCl. Sodium nitrite and HCl. At what temperature? 0 to 5 degrees Celsius. Okay. So what is the product you are going to get? The aniline, amine part is converted to what? N2 plus Cl minus. Benzene diazonium chloride. This process is called what? Diazotization, right? Diazotization reaction. Conversion of aniline into diazonium salt is known as what? Diazotization reaction. You know very well this compound having lot of application in chemistry. You can prepare chlorobenzene, bromobenzene, iodobenzene, fluorobenzene, phenol, benzene, so many things from benzene diazonium chloride. Here we need chlorine. Okay, let's prepare. Two methods are there. You studied very important two reaction, Sand-Meyers and Getterman reaction. Yes? Fine. What is Sand-Meyer reaction? We are using CuCl or Cu2Cl2, cuprous chloride. Cuprous chloride with what? HCl. We will get chlorobenzene. One more method you studied, instead of CuCl, we are using copper powder. Copper powder with HCl. Again same product, chlorobenzene. The first reaction is known as Sand-Meyer reaction. The copper powder using reaction is called which one? Getterman reaction. So chlorobenzene can be prepared by reacting aniline with which one? Hydrochloric acid, cuprous chloride. Yeah, CuCl is called cuprous chloride, but careful. Simply cuprous chloride, if you add into aniline, it can happen? No. First diazotization. What is that? Chlorine in presence of anhydrous aluminum chloride. No, that is electrophilic substitution. Nitrous acid. Dear student, what is meant by nitrous acid? HNO2. You know, nitric acid is called HNO3. Nitrous acid is called what? HNO2. What is HNO2? It is hiding here, okay? Careful. Can you see NaNO2 and HCl? What is NaNO2? Sodium nitrite along with the HCl, hydrochloric acid. You please mix these two reagent together. NaCl, okay? Byproduct is NaCl. What is the major product? HNO2. Okay, HNO2 actually the reacting species here. So either they will give you NaNO2 and HCl, or they can give you HNO2, nitrous acid. That both are diazotization. Okay, so first of it treated with the nitrous acid, followed by heating with the cuprous chloride, CuCl. Okay, fine. That's the product. Option D is the reaction. Okay, next question. Question number 14. Which one is the most reactive towards SN1 mechanism? You know the major order for SN1 mechanism for the haloalkanes. What is the order? Tertiary greater than, secondary greater than, primary. You may study it beyond that. Tertiary greater than, benzyl greater than, allyl greater than, secondary, primary, methyl, vinyl, etc. Here I think majority they will ask you questions with which one? The carbocation stability. I'm just rewriting all the compounds, okay? Option A, I'm just rewriting C6H5. What is meant by C6H5? Phenyl ring. Okay, phenyl ring with a CH on which a bromine and one more benzene ring is there. Alright, this is the first compound. Option B is given C6H5. Okay, C6H5 and then one CH carbon. There is a bromine and we have CH3 here. Alright, correct, right? Okay. Next one, option C. Option C is given C6H5. Okay, C6H5. Then C, one carbon. On that carbon, what all things you have? One CH3 is there. Again, one more phenyl ring. And there is a bromine. Last one, C6H5CH2Br. Option D is given C6H5CH2Br. Okay, these are the reactions given. Dear all of you, you don't expect always SN1 mechanism. They will ask you questions related to tertiary greater than secondary greater than primary system. They will ask you some others. Okay, very careful. The most questions you can follow this reaction. You know, tertiary carbocation greater than, benzyl carbocation greater than, allyl carbocation greater than, secondary greater than, primary greater than, methyl carbocation greater than, then only we have vinyl carbocation. This mechanism or this order you have to follow. Okay. What is happening in SN1 mechanism in the first step? Removal of halogen, formation of carbocation. Remove the halogen, all of you. I'm removing this bromine. This is a carbocation. Removing this bromine, carbocation. Removing this bromine, carbocation. Bromine, carbocation. Can you identify which all carbocations are given here? This carbocation directly connected to 2 carbon atom. Therefore, it is a secondary. This carbocation directly connected to 2 carbon atom left and right. Therefore, it is again secondary. This carbocation directly connected to 1, 2, 3 carbon. Therefore, it is tertiary. And here the carbocation is which one? Actually, it is a primary carbocation other than it is benzyl carbocation. Whatever which is more stable, dear all of you. Tertiary carbocation is more stable. So this species will undergo reaction so faster. So your answer is which one? Option C. Clear? Okay. Next one. Question number 15. An aromatic ether is not cleaved. Chapter is which one? Alcohols, phenols and ether. A aromatic ether is not cleaved by HI. You know, when you react with HI, HB or something, a hydrogen halide, the bond, CO bond in ether can be break. Correct. Which won't break? That's a question. Option A, I'm just rewriting. C6H5OCH3. What is that? Anisole, right? C6H5OCH3, or we call methoxybenzene or anisole. What is option B? There are 2 benzene ring, all right? 2 benzene ring is there. 2 benzene ring, and there is oxygen, one another. Okay, phenyl rings are there. Okay, fine. This is the compound. Second compound. Option C, C6H5, oxygen, C3H7, that's what? CH2 propyl group. CH2, CH2, CH3, right? C3H7. Option D is given to a tetrahydrofuran. It's a heterocyclic compound. You know, you may studied about furan in the biomolecule chapter. All right. So, dear all of you, an aromatic ether is not cleaved by. Which of the following cannot be cleaved by HI? That's a question. Okay, HI. See. When you treat it with HI, you know that if it is anisole, you will break here because, you know, oxygen negative, carbon positive. This is called phenoxide ion. Phenoxide ion is highly stable. But in option B, there is a problem. Here the oxygen atom, it is directly connected. See these 2 carbon atom. What is the hybridization of this carbon? This carbon is a double bonded carbon sp2. This also double bonded carbon sp2. Dear all, 2 sp2 carbons are connected with the oxygen atom. You know, sp2 carbon mean it having little greater electronegativity. So these 2 carbon which are bonded with the oxygen are highly electronegative carbon. So the bond is little strong. We cannot break it even at 525 Kelvin. Okay, so this is the compound. You cannot be cleaved by treating with HI. What about here? Here also you can cleave here, by the way, to get a phenoxide ion, because this carbon is sp, this carbon is sp2, this carbon is what? sp3. Here S character is little less. But here this oxygen, this is what? sp3, this is again sp2, same situation. Here both are sp3 carbon, right? So sp2 carbon, if the oxygen connected, it's little strong bond, we cannot break it easily. Okay, so we can go for the next question. Question number 16. Which of the following compound is good conductor of electricity in solution state? I think the question is related to solid state chapter. Which is a good conductor of electricity in solution state? Which one? Covalent or molecular or metallic or ionic solid? Which one, dear all of you? Ionic, right? You studied that ionic crystals can conduct electricity in their molten state, correct? Yeah, ionic is the little covalent or the conducting one, the conducting one. Next one, question number 17. The compound which react fastest with Lucas reagent. We know very well Lucas reagent chapter, alcohol, phenols and ether. Lucas reagent mainly we are using to identify whether the compound is primary, secondary or tertiary alcohol. Correct. To distinction test. What is Lucas reagent? Concentrated HCl with anhydrous zinc chloride. You know what is the reactivity order of alcohol with Lucas reagent? The order is what? Tertiary greater than, secondary greater than primary. Why tertiary alcohol interacting, or tertiary alcohol when react with the Lucas reagent, it will give immediate turbidity. And what about secondary alcohol? Secondary alcohol will give turbidity after 5 minutes because its reactivity little less. Primary alcohol which won't react in normal condition, only it give turbidity by heating, which means it is very less reactive. So question which is fastest reactive with the Lucas reagent. So question which is a tertiary alcohol. What is, dear student? Option A, butane 1-ol. Butane means 4 carbon with alcohol. It is a primary alcohol, right? OH connected carbon directly connected to 1 carbon primary. Option B, butane 2-ol. Butane 2-ol, dear student, you know very well it is a secondary alcohol. 2-methyl propane 1-ol. 2-methyl propane 1-ol. It's again primary alcohol. What about option D? 2-methyl propane 2-methyl propane 2-ol. Yes, it is a tertiary alcohol. It can undergo reaction so faster. Right. So Lucas reagent reaction can happen more in which one? Option D. Next question. Question number 18. Consider the formation, breaking and strength of hydrogen bond. Predict which of the following mixture will show a positive deviation from Raoult's law. Positive deviation. You may study a lot of example for positive deviation and negative deviation for the ideal solution, non-ideal solution categories, right? Non-ideal solution again we classify into 2, positive deviation and negative deviation from the chapter solutions. You may study a lot of example. Methanol and acetone, you may study methanol with acetone, ethanol with acetone, all are belongs to positive deviation. Nitric acid and water belongs to negative deviation. Chloroform and acetone belongs to negative deviation. Phenol and alanine also you may study under negative deviation. So the only one compound which shows, or the solution or the mixture of solvents can show positive deviation, that's option A. Next question. Phenol is less acidic than, dear all of you, what is called phenol? Benzene with OH. You know very well, phenol is more acidic compound because phenol is ready to leave this hydrogen as H plus ion because it forming a phenoxide ion. It is more stable due to resonance. Correct. Phenol is less acidic than which of the compound? Which means the question in option A, B, C, D, which is more acidic. Correct. What is option A? Ethanol. Ethanol, of course, it is a less acidic one compared to phenol. Because even though if you remove this hydrogen, there is no resonance stabilization. So not option A. Option B given orthonitrophenol. Okay, so there is phenol again there, or ortho position nitro group. Next one, C. Orthomethylphenol. Orthomethyl. This is phenol, ortho position, there is a methyl group. And option D is given orthomethoxyphenol. Orthomethoxyphenol, OCH3 group. You know what is a major factor affecting acidity? Electron withdrawing group and electron donating group. We studied that electron withdrawing group, if it is there, they will increase the acidity. Electron donating groups can decrease the acidity. Let's check it, which all are electron donating, which all are electron withdrawing. Dear all of you, nitro group, very strong electron withdrawing group. Alkyl groups are electron donating group. Alkoxy groups also electron donating group. So which is more acidic? Option B, right? Option B, because it contains electron withdrawing group, they can increase the acidity. So question, phenol is less acidic than this one because it is more acidic due to the presence of a electron withdrawing nitro group in the ortho position. Question number 20. The catalyst used in the manufacturing of HNO3 by Ostwald process. Chapter P block. Right? In 15th group. Nitrogen family. You may study ammonia. Ammonia industrially prepared through the reaction called Haber process. Right? Haber process. Where the catalyst we are using iron. But here it is called Ostwald process. The industrial commercial preparation of nitric acid is known as what? Ostwald process. What is the catalyst using? You may study platinum gauge, right? At high temperature, platinum gauge. Your answer is option A, platinum gauge. It is the catalyst used in the manufacturing of nitric acid through Ostwald process. Question number 21. The number of bonds between sulfur and oxygen, okay? Sulfur and oxygen atoms in S2O8 2- and the number of bonds between sulfur and sulfur atom in rhombic sulfur, okay? It is here. Rhombic sulfur, you know, S8. You know, rhombic sulfur and monoclinic sulfur, the both of the component contain S8 unit common, right? Okay. So question is simple. How many sulfur oxygen bonds are there? They didn't specify sulfur oxygen single bond or double bond. Okay, so all we can consider. How many sulfur oxygen bonds are there in this ion and how many sulfur bond in S8 rhombic sulfur? Let's calculate. What is this species? S2O8 2- dear all. You may study one of the oxo acid of sulfur. That's called H2S2O8. That's called what? That's called what? Peroxo disulfuric acid. H2S2O8 is called what? Peroxo disulfuric acid. So from this, if you lose this hydrogen atom, you will get S2O8 2- because this 2 hydrogen is leaving as 2H plus. So the ion will be this one. You know what is the shape of peroxo disulfuric acid? Let me draw. S double bond O, OH. S double bond O, OH. In between what you have? There is a peroxide linkage, OO linkage. This is the structure of which one? Peroxo disulfuric acid, H2S2O8. What is this ion represent? If these 2 hydrogen gone as H plus ion, the remaining species is called S2O8 2- ion. Can you tell me, can you please count total how many sulfur oxygen bonds are there? 1, 2, 3, 4, 5, 6, 7, 8. I think there are 8 SO bond. So answer is here it is 8. You know how S8 rhombic sulfur is existing with a crown shape, right? A butterfly like a crown shape. You may notice that. Right. A crown shape. 1, 2, 3, 4, 5, 6, 7, 8 sulfurs are there. Can you tell me between the sulfur total how many bonds are there? 1, 2, 3, 4, 5, 6, 7, 8. Yes, there is also 8 bonds are there. So what's your answer? 8 and 8. Option B is the answer. So dear all of you, it's very essential to study the oxo acids of sulfur, chlorine and phosphorus, their structure, formula and their acidity order. Alright, next question. Question number 22. Elimination of bromine from 2-bromobutane. What is 2-bromobutane? CH3CHBr, CH2, CH3. Haloalkane chapter. This is the compound called 2-bromobutane. The elimination of bromine, you know bromine elimination, that's called what? Beta elimination or dehydrohalogenation. What is the reagent we are using? Alcoholic KOH, right? Beta elimination. What is beta elimination? Halogen is eliminated from alpha carbon. One hydrogen is taking from beta carbon. But there are 2 beta carbon dear all. Which beta you will take predominant? I think the right one. Because according to, if you're taking hydrogen from left beta, you have to take a double bond here. Then it will be but1ene. If you are taking hydrogen from the second, this beta, then double bond will be here. That's called but2ene. Which is the major product? But2ene. According to Zaitsev rule. According to Zaitsev rule, you know, more substituted alkenes are more stable. So try to take hydrogen almost from from the center. Okay, so bromine I am taking from this carbon, alpha carbon, hydrogen I am taking from beta carbon, make a double bond between alpha beta. Product will be CH3, CH double bond, CH single bond, CH3. But 2-ene will be the major product. You will get but 1-ene also, okay? You can take hydrogen from here also, then but 1-ene is the product, but that is minor, but 2-ene is the major. So what's your answer? Predominantly 2-butene. Option C is the correct answer. Yes, predominantly 2-butene will be the product. We can go for the next question. Which of the following is an example of vicinal dihalide? You know what is meant by vicinal and geminal dihalide, right? What is meant by vicinal? Vicinal dihalide means if the halogens, for example chlorine, if they are on the adjacent carbon atom, if two halogens are present on adjacent carbon atom, it is called vicinal. If both of the two halogens are on same carbon, is called what? Geminal, right? Geminal dihalide. Let me draw the shape of the compound. Option A, dichloromethane. You know, methane means one carbon. Dichloro, there are two chlorine. So we can say CH2Cl2 is called dichloromethane. Option B, 1,2-dichloroethane. This is ethane. 1,2, right? Yes, 1,2. First and second position, 2 chlorine. Option C, ethylidene chloride. What is ethylidene chloride here, all of you? CH3, CH. This is called ethylidene dichloride. This is called ethylidene dichloride. Option D, allyl chloride. What is allyl chloride? You know, this group is called vinyl with one more carbon is called allyl with chloride. Tell me which is a vicinal dihalide? Very simple. No, this is a geminal dihalide because both of the halogens are on the same carbon. This is again option C is geminal dihalide. Both chlorine are same carbon. Option B is the vicinal one. Option B, because both of them are on the same adjacent carbon atom. But option D, allyl halide, allyl chlorides are which one? A monochlorinated one. Alright, so your answer is option D. Next one. Question number 24, optical rotation of some compounds along with their structures are given below. Which one having D configuration? D configuration. Chapter is which one? Biomolecule, right? You may study what is D and L configuration. What is D and L configuration? We studied due to by using a simplest aldehyde, glyceraldehyde, right? Let me take 2 glyceraldehyde. All right, this is glyceraldehyde. What is glyceraldehyde? This carbon is CH2OH. This is CH2. Same here, CH2OH, CH2. If on this chiral carbon OH right side and H left side, then it is called D configuration, D-glyceraldehyde. If OH left and hydrogen right, then it is called L-glyceraldehyde. Correct? Yes. So, if you can observe this one, if you can observe this part, in the below area of this the carbohydrate, you can say it is D configuration. If you can observe this arrangement, means OH left side below part, you can observe it is L configuration. Let's see. In the first compound, all of you just mark the area which I mentioned here. This is the one. Always this group you can observe in the bottom part. Okay. What about here? This is the area. Here it is. This one. Now observe where is the OH located. Here OH right side, D configuration. OH right side, D. OH right side, D. Yes, same like this. So all of them having D configuration. 1, 2, 3 is the correct answer. Easy, right? Next one. Question number 25. At a given temperature, osmotic pressure of a concentrated solution of a substance is. You know, it's related to the chapter solutions colligative property. You know, osmotic pressure pi is a colligative property. What is a colligative property? It depends on the number of particle, not on the nature of the particle. Alright, so more the number of particle, you know, more osmotic pressure. So at a given temperature, osmotic pressure of a concentrated solution. What is meant by concentrated solution? There are a lot of particle. There are a lot of solute particle. That's called concentrated solution, right? So for a concentrated solution, especially osmotic pressure will be always high. Why? Osmotic pressure is a colligative property. Colligative properties depends on the number of particle. As the number of particle increases, which particle? Solute particle increases, the osmotic pressure also increases. So for a concentrated solution, osmotic pressure is already very high. Then the question, osmotic pressure of a concentrated solution of a substance is there something they are comparing. Option A is higher than that of diluted solution. Yes, dear student, let's go with option A. For a concentrated and dilute solution, when you consider concentrated solution contains so much particle, so osmotic pressure greater. For dilute particle, number of particles are lesser, so the osmotic pressure is lesser. Right, option A is the answer. Next one. Let's go to, so out of 25 question, section A having 25 question, among that you have to answer 20, any 20 questions. Okay, so perfectly carefully read all the questions and try to understand or try to identify which all questions you can able to answer with more confident, with more accurate. Okay, so we are going to question section B, question number 26. Which is the correct increasing order of boiling point? Increasing order of boiling point. Dear student, boiling point mainly depends on two factors. First one is their molecular weight. Greater the molecular weight of a compound, greater will be the boiling point. Correct. Second factor, if they are giving some of isomers, suppose they are having same molecular formula or the mass, what we have to do? We are checking the branches or the components, right? As the number of branching increases, what happens to boiling point? Boiling point decreases. Correct. So first factor, mostly we have to consider the molecular weight. Greater the molecular weight of a compound, greater will be the boiling point. Second factor, branching. Number of branching greater in a system, lower will be the boiling point. Let's go. Compounds are given. The compounds I am just noting. The compounds are given 1-bromoethane. 1-bromoethane. So I am just not writing completely, just like this. 1-bromoethane. Second one, 1-bromopropane. Okay, 1-bromopropane means 3 carbon with bromine. 1-bromobutane. So 4 carbon with bromine. Okay. What about the last one? Bromobenzene. Okay, this is the one. Can you tell me, dear student, which one having greatest mass first of all? I think no doubt bromobenzene, right? Which one having greatest mass? Bromobenzene. Because there are 6 carbon atom, bromine and remaining hydrogen atoms are there. So greater weight is for this one, so greater boiling point. After that, no doubt, this one, because there are so many carbon, and this. So your answer is which one? First bromobenzene, then butane, then propane, then ethane. Shall we go with option D? Yes. Alright. Next simple question. Next one. The secondary structure of a protein refers to chapter biomolecule structure of protein. Secondary structure of protein further classify into two. They are called alpha helix and beta pleated. Right? Alpha helix and beta pleated. Anyone is there? Fixed configuration of the polypeptide backbone? No. Alpha helical backbone? Yes. Alpha helix and beta pleated are the most common secondary structure of a protein. Next. A brown ring is formed in the ring test for nitrate ion. Even in laboratory also, in the salt analysis, you may do that for the detection of the nitrate NO3 minus ion. You're doing a confirmation test, right? Brown ring test. What is brown ring test? You will take the sample to which you are adding ferrous sulfate FeSO4, and through the side of the test tube you are adding, without shaking the test tube, you are adding concentrated sulfuric acid. You can see there is a brown ring formed in the junction of that two liquids. What is the chemical formula of that brown ring? You may study that brown ring compound having 1 ion. Study like this. One in brown ring contain 1 ion. Okay, 5 water. 1 nitrogen monoxide nitrosyl with a charge 2+. This is the compound. 1 Fe, 5 water, 1 NO group with a 2+ charge for the overall complex. Your answer is which one? Option A. It is a detection of which ion? Nitrate ion, right? Brown ring we are using for the detection of nitrate ion. Chapter P block. Question number 29. The COH bond angle in ethanol is nearly. Chapter Alcohol, Phenol and Ether. In the beginning topic of the alcohol chapter, you may study normally if you consider a alcohol, for example, methanol, CH3OH, oxygen containing two lone pair. What is the bond angle? You may study around it is 109 degree. Exactly, it is around 108.9 degree. Okay, almost 109 degree. So normal alcohols, aliphatic alcohols having this much bond angle. Now, what about ether? Ether, for example, CH3OCH3, there is also two lone pair. What is the bond angle? It is a little greater, 111.7 degree. Why? Why alcohols 109 and in ether greater? Because there are two bulky group. In order to avoid the repulsion, bond angle greater. Alright. So in ethanol, what is the bond angle? This is about methanol. What about ethanol? Nearly 109 degree. There is no large difference, right? Which is the bond angle nearly 109 degree? That is 104 degree, right? Yes. Next one. Electron gain enthalpy. What is another name of electron gain enthalpy which you studied in P block chapter? Electron affinity. Electron gain enthalpy with a negative sign of fluorine is less than that of chlorine due to. Dear student, fluorine, chlorine, bromine, iodine. When you studying the electron gain enthalpy or electron affinity order, you may study that you have to switch these two elements. Chlorine and fluorine, just switch it. Because chlorine having greater electron gain enthalpy than fluorine, then bromine, then iodine. Why? Actually, down the group, we are expecting more negative electron gain enthalpy, less electron. You know how to period and group electron gain enthalpy or electron affinities vary. When you discussing halogen family, fluorine, chlorine, bromine, iodine, there is a small change, even in oxygen family also. So, fluorine halogen family, when you consider chlorine having more electron gain enthalpy than the fluorine. The reason, fluorine is a smaller atom. Correct. Fluorine is a smaller atom having 7 electrons in their outermost shell. Already, because of the small size, all electrons are very nearby. There is a greater electron-electron repulsion in the system. So, can you add one more electron to the outermost shell? No. There will be again repel. So, fluorine, the electron gain enthalpy lesser than chlorine. So, answer is which one, dear student? Because of high ionization enthalpy? No. Small size of chlorine? No. Small size of fluorine atom? Yes. And bigger size of 2p? No. So, because of the smaller size of fluorine, all electrons are very nearby. So, there is a greater electron-electron repulsion. So, addition of one more electron is very difficult in fluorine. Okay. So, chlorine having greater electron gain enthalpy. Next question number 31. The presence or absence of a hydroxyl group on which carbon atom of sugar differentiate RNA and DNA? You know very well what is the name of pentose sugar. Chapter which one? Biomolecule. What is the pentose sugar part in DNA and RNA? The RNA containing pentose sugar, you will draw maybe like this. You may study the structure, everything. Here we have CH2OH, H, HOH, HOH, OHH. This is the pentose sugar in RNA. What is the pentose sugar in DNA? Same here, CH2OH, H, HOH, HH, OHH. You know the number of carbon atom? Number 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Tell me, dear all of you, what is the name of the pentose sugar present in RNA? You know very well. What is that? Beta D ribose. Yes or no? This is called what? Beta D ribose. What is the pentose sugar in DNA? In DNA, the pentose sugar is called beta D 2-deoxyribose. Beta D 2-deoxyribose. What is the difference between beta D ribose and beta D 2-deoxyribose? A small term, 2-deoxy. Second position, there is no oxygen. Can you identify? This is the second carbon, right? Can you see any oxygen here? No. In the second carbon here, can you observe? Yes, oxygen is there. So the pentose sugar in RNA is beta D ribose. In DNA, it is what? Beta D 2-deoxyribose. Second position, there is no oxygen in the DNA. So what is that? In which position the oxygen or hydroxyl group, which one is absent? That is in second position only. The configurations are different, or the species are different. Next one. Question number 32. Very important question. Question is related to, I think, P block chapter. Okay. Which of the following statements are correct? Okay. Natural abundance of noble gases. You know noble gases, 18th group element. Their abundance in nature is approximately 1% by volume, of which argon is the major constituent. Read NCERT carefully, all of you. This is the correct statement. Okay. Natural abundance of noble gases are approximately just 1%. Among that, argon is the predominant one. Second option given, noble gases have high positive value of electron gain enthalpy. You may study it. Electron gain enthalpy can be two value. Positive value you can express either in negative value. Which species having positive value, which species having negative value? Those species which are not ready, those species which are not ready to accept electron in their system, generally electron gain enthalpy will be positive value. Those species are ready, to accept electron in their system, the electron gain enthalpy will be negative. Alright, so in halogen family we said no, they are having more negative electron gain enthalpy because halogens are ready to accept electron. But positive electron gain enthalpy means those systems are not ready to accept electron. For example, mostly positive electron gain enthalpy possessed by, you may studied metals. You know, metals are electropositive element. They are ready to lose the electron, not to gain. Another one, noble gases. Noble gases also don't want electron, right? So generally, metals and noble gases having positive electron gain enthalpy. Let's go. So noble gases have high positive value. Yes. Preparation of XeF2 require F2 in excess amount, right? You may study the preparation of XeF2, XeF4, XeF6. XeF2 we are preparing by Xe plus F2. We will get XeF2 where we are using xenon in excess quantity, right? You know the condition 673 Kelvin, 1 bar pressure, like that. So xenon should be in excess, not fluorine in excess. That is wrong. Complete hydrolysis of all three, XeF2, XeF4, XeF6, give Xe as one of the product. I think no. Let's see. You studied the complete hydrolysis of the compound XeF2, XeF4, XeF6. Complete hydrolysis means what? Reacting with water, right? Reacting with the water. Can you tell me, dear student? XeF2 on hydrolysis you may study it. It will give you three products. What are they? Xe, HF and O2. XeF4 on hydrolysis, the same three product you will get it back. Xe, HF, O2. One more product excess, that is called XeO3. XeF6 on hydrolysis, it will give you only these two products, which all XeO3 and HF. So they're saying that XeF2, XeF4, XeF6 on complete hydrolysis will give xenon as one of the product. Is it? No. XeF2 will giving xenon, XeF4 giving xenon, but XeF6 not giving xenon. It is giving XeO3 and HF. So that's also wrong statement. Question, which of them are correct? Only 1 and 2 are correct. Option C is the correct answer. Next question. Which of the following fluoride of xenon is impossible? Very simple question. What is that? B. Dear students, xenon compound, you know, very familiar. XeF2, XeF4, XeF6, etc. These are easy one. It can form even number. Xenon maximum try to make a bond with an even number of fluorine, not odd number. Therefore, XeF, XeF3, XeF5, these kind of compounds are not existing. You know the reason very carefully. There is xenon having 8 valence electron. It is surrounded by, suppose it is surrounded by 3 fluorine. You know, each fluorine need 1 electron, a lone pair, just 1 odd electron. Odd electron species are, very unstable. At the same time, they cannot complete octet. The rule is violating. So xenon not ready to combine with the odd number of fluorine, only with the even number. So XCF3 is not possible. Then a numerical question from the chapter, I think, density of calculation, solid state. An element with atomic mass. So atomic mass M is given 100 gram per mole. Having BCC structure, BCC system means the number of atoms per unit cell, Z value is equal to 2, has a unit cell edge length or axial length 400 picometer. Density we are calculating in gram per centimeter cube, so your edge length or axial length must be in centimeter. So picometer, how can we convert into centimeter? By 10 to the power minus 10 centimeter. Okay, picometer, 400 picometer means if you multiply by 10 to the power minus 12, it becomes meter, 10 to the power minus 10, it becomes centimeter. Okay, then what about the density? What is the equation for density? Simple equation, Zm divided by Avogadro number into A cube. Substitute Z value 2, molecular mass 100. What is Avogadro number? 6.022 into 10 to the power 23 into what is A value? 400 into 10 to the power minus 10, the whole cube. Okay, so all of you work out it, almost you will get 5.8188 gram per centimeter cube. Option C can be the answer. Then question number 35, question is related to haloalkane chapter. Aryl halide, what is aryl halide? A aromatic halide, a halogen connected to benzene ring. Aryl halide cannot be prepared by the reaction of aryl alcohol. Okay, aryl alcohol, let me take it like aryl alcohol is phenol with PCl3 or PCl5 or thionyl chloride SOCl2. Correct. A normal aliphatic alcohol, methanol, ethanol, propanol, everything you can convert into their chloride by using this kind of chlorinating agent. But a aryl halide, it is not possible. What's it? Phenol are highly stable compound. Is it? Not a highly stable one, it can undergo reaction, right? Carbon oxygen bond in phenol has a partial double bond character. Yes. A normal alcohol, for example, methanol, when you treat it with these reagent, you will get methyl chloride. Correct? Means this OH you can replace, chlorine you can substitute, easy one. But in aryl alcohol, that this OH, this bond is involved in resonance. So there is a carbon and oxygen try to make a partial double bond character. Double bond is a stronger bond. So the removal of OH group is little difficult in aryl alcohol. If you remove the OH group fast, then only you can add one chlorine, right? So OH removal is little difficult. So what we can say the answer? Option B. Carbon oxygen bond in phenol has a partial double bond character. Carbon oxygen bond is highly polar. Carbon oxygen bond is actually, it is polar one, but not a factor affecting this reaction. So carbon oxygen bond is very stronger one. That's the reason, but therefore you cannot remove OH group. So answer is option B. Next one. Aryl fluoride. For example, aryl fluoride means what? A benzene ring with a fluoride. Aryl fluoride may be prepared from arene diazonium chloride. Yeah, same thing we studied like our Sandmeyer's and Gattermann reaction. In that category, we studied one another reaction. What is called? You may study that the starting material, let me take aniline, right? Aniline is called NH2. Then what we are doing? We are just treated with NaNO2 and HCl at 0 to 5 degrees Celsius. We are getting the compound benzene with N2 plus Cl minus. Diazotization done. Alright. After that, we are doing the process. A student question, we want to get fluorine. If you want to get chlorine, we are doing Sandmeyer, Gattermann, such kind of reaction. If you want to add fluorine, what is the reagent we are using? We are using the compound HbF4, that is called fluoroboric acid, right? HbF4 is called fluoroboric acid. After that, heating. If you want to convert benzene diazonium chloride into which one? Fluorobenzene. We have to treat it with HBF4, fluoroboric acid. After that, heat. This reaction you may studied one name. The conversion of diazonium salt into fluorobenzene is called what? Ball-Schiemann reaction. Ball-Schiemann reaction. Ball-Schiemann reaction. So what is that? HBF4 with the heating, that's enough dear all of you. HBF4, NaNO2, copper on heating you will get nitrobenzene, okay, not that. HBF4 then heating. Next one. On sulfonation of C6H5Cl. What is C6H5Cl? That is chlorobenzene, again the chapter haloalkane, haloarine. This is chlorobenzene on sulfonation. During nitration, if you want nitro group as an electrophile, normally we are using nitrating mixture, concentrated nitric acid and sulfuric acid. If you want to do sulfonation, just concentrated sulfuric acid is enough, or we are treating with which one? Oleum, right? So I'm taking fuming H2SO4 or the sulfuric acid, or a fuming sulfuric acid oleum. You know, sulfonation means addition of which group? SO3H group as an electrophile. Okay, where we can add, that is a question. To which position this electrophile can attack? That's decided by the existing group on benzene ring. What is existing group? Chlorine. You know, halogens on benzene ring act as a ortho-para directing group. So the SO3H can goes to ortho position, even they can goes to para position. You will get both product. You know, benzene with the SO3H is called what? Benzene sulfonic acid. Benzene with SO3H group is called what? Benzene sulfonic acid. So what is this called? You know, sulfonic acid is a major group here. This is ortho position. So orthochloro benzene sulfonic acid, parachloro benzene sulfonic acid. So your answer is mixture of, yes, mixture of ortho and parachloro benzene sulfonic acid are the product. So it's very important to know the ortho para meta directing group, which all are ortho para, which all are meta directing groups. All right, next one, question number 38. What is the IUPAC name of metacresol? You know very well what is cresol. Cresol means phenol with a methyl group. If the methyl group in ortho position is called orthocresol. If it is in meta position is called metacresol. What is the IUPAC name? Major group is alcohol. So number 1, number 2, number 3. Third position there is a methyl group. Therefore 3-methyl. What is the remaining compound is called? Phenol. 3-methyl phenol. 3-methyl phenol. 3-methyl phenol. Option A can be the answer. Alright. Next one. Which of the following is not a characteristics of fibrous protein? Chapter biomolecule. You may studied biomolecule chapter. Proteins can be classified into two. What are they? Fibrous and globular protein. Fibrous protein. Option A, all of you read it. In the fibrous protein, polypeptide chains are held together by hydrogen and disulfide bond. Very correct statement. These having fiber-like structure, of course, therefore they are called fiber protein. These are generally soluble in water. No dear, no. We studied fibrous proteins are insoluble in water, globular proteins are soluble in water. That is a wrong statement. And these have elongated shape. That's also correct. So only the incorrect statement is option C. Question number 40. If Z is the number of atoms in the unit cell, for a packing system ABC, what is the total number of tetrahedral void? You know very well. If there are Z number of spheres in the unit cell, there will be Z number of octahedral void and 2Z number of which one? Tetrahedral void. Yes or no? Yes or no? If there are Z number, or you may study that N number, right? If there are N number of spheres in the unit cell, there will be N number of octahedral void, double number of tetrahedral void. It is Z, therefore Z number of octahedral, 2Z number of tetrahedral. So 2Z will be the answer. Solid state chapter. Next one. Question number 41. Which of the following pair of ions are isoelectronic and isostructural? Isoelectronic means they are having same electron, same number of electron. Isostructural means same structure. Let's find out. Option A. CO3 2- carbonate ion. Option B given, nitrate ion. Okay. Which is the central atom here? In carbonate ion? Carbon. What is the valence electron of carbon? 4. Can you see there is a 2 minus charge? 2 minus charge means you have to add 2 more electron. Okay, fine. It is surrounded by how many oxygen? 3 oxygen. 1, 2, 3. You know, each oxygen carrying 6 valence electron. So each oxygen need 2 more electrons to complete their octet. Okay, let them take electron. Each oxygen need 2 electrons. This is the system. Okay, fine. NO3 minus, which is central atom? Nitrogen. What is the valence electron of nitrogen? 5. Can you see negative charge? Means add 1 more electron. There are 3 oxygen atoms. Each oxygen need 2 more electrons. Are you feeling their same system? Yes. Dear student, on the carbon total you have 1, 2, 3. There are 3 bond pair and 0 lone pair on carbon. So structure is what? Trigonal planar. We can draw like this. Actually, you know, they are not making a double bond on each oxygen atom. They are trying to make a coordinate bond. You know how it is actually existing. These all are single bond. These all are single bond actually. Right. And what about NO3 minus? NO3 minus means nitrogen, the same situation. So are they having same number of say electron means let's count later. Are they having same number of same structure or not? Yes. If the central atom contain same number of bond pair and lone pair, their structures also similar. What about their electron number? I think they are same. Or you can count like this. You know, carbon. How many electron on one carbon? 6 electron. How many electron in one oxygen? 8. 3 oxygen, 3 into 8. Right. 24 plus 2 minus mean add 2 more electron. So 24 plus 6, 30, 30 plus 2, 32 electrons are there in the whole molecule. What about NO3 minus? Nitrogen contain how many electron? 7 electron. 3 oxygen contain 24 electron. Minus mean add 1 more electron. 24 plus 1, 25, 25 plus 7, 32 electrons. See, they are also having same number of electron. You know the exact structure of carbonate ion, right? C double bond O. These two are single bond actually, not single bond. What is called? Coordinate bond. Alright, so their answer is option A itself. They're having same structure, same number of valence electron. Next one, an important question. Which one of the following will most readily be dehydrated in acidic condition? I think all are alcohol. You know, alcohols can undergo dehydration, means elimination of water. It will give you alkene. What is simply a beta elimination? For example, I am taking the compound CH3CH2OH. You know, OH connected carbon is called alpha carbon. Nearby carbon is called beta carbon. From where we are going to eliminate water? You know, OH you are taking from alpha carbon, one hydrogen you are taking from beta carbon, make a double bond between alpha beta, finish. This is called dehydration. So question, which of the following alcohol can undergo dehydration so faster? Okay, let us remove water. Let's see which alkene is more stable. Then it will undergo reaction faster. Okay, let me take the OH group from this alpha carbon. This is beta, this is beta. Which beta you can select? Or from which beta you are ready to take a hydrogen? I prefer the left beta because try to make almost the double bond in a more crowded area or a substituted area. That is called what? Zaitsev rule, more stable product. So alpha here, I am taking beta this one. So double bond is here. Okay, double bond is here. So first compound after dehydration, this will be the situation. Okay, this will be the situation. What about option B? OH I am taking from alpha carbon. This is beta, this is beta. Which beta you will select? I think right one. Then the double bond is in the crowded area, more stable. So I am taking this beta, all of you. So you will get this compound. Option C. OH I am taking from this alpha carbon. This beta carbon doesn't contain any hydrogen. So we should take beta from this one. So double bond is here. So we can draw the structure like this. Alright. Next, options D. OH you can take from this carbon, hydrogen, both are same one. Okay, you can take from any side. Suppose I am taking this is beta, both are same type. No other data are following. Double bond O. Here we can write is the double bond position. Okay, yes. Now all of you please observe which alkene is more stable. That's a question. Which alkene is more stable? I prefer to undergo option A. Why? You know, this double bond is a more substituted, right? More substituted components are there. This alkene is more substituted. Even it is in conjugation with a double bond, it can undergo resonance. More stable. Option B, no resonance possible here. Option C, it having one resonance. One resonance is possible. But when you compare option A and C, this is the most substituted alkene. According to Zaitsev rule, this is the most important, most major product. So this is also not there. Option D, this double bond is not in conjugation with this pi bond, cannot make any resonance. So option A, the compound can give a most stable alkene. So he will undergo reaction faster. Option A is the answer. Okay. 43 question. Which of the following statements are correct? 1. In phenol, the OH group is attached to. Okay, what is phenol? Benzene with OH. In phenol, the OH group is attached to a sp2 hybridized carbon atom in the aromatic ring. Yes, correct statement, right? OH connected carbon, this is the one. It's a double bond connected carbon, sp2. Correct statement. The carbon-oxygen bond length in phenol. So they asking about phenol. Okay. The carbon-oxygen, where is the carbon-oxygen bond? This is the bond, CO. The carbon-oxygen bond length is 136 picometer, okay, 136 picometer in phenol is slightly more than that of methanol. Slightly more than that of methanol. Are you agree with that? I think no. Because dear, phenol, the carbon oxygen, we studied that it can make a resonance and they will try to bring a double bond here, a double bond here. But methanol cannot make a double bond, it exists as a single bond, which is shorter in length, double bond, because it is stronger. Correct. So double bond is stronger, therefore it is shorter in length. So CO bond in phenol is shorter than methanol. They are saying more than methanol. No. Option 3. Partial double bond character is due to the conjugation of unshared pair of electron on the oxygen atom in the aromatic ring. Yes or no? Yes. They can, phenol, the double bond is formed by the resonance structure, conjugation. Phenol has sp2 hybridized state of carbon to which oxygen is attached. Yeah, same definition like first one. That's also correct. So which all are correct statement? 1, 3, 4. 1, 3, 4. Option C is the answer. Next question. A solution of sucrose, a numerical from the chapter solution. A solution of sucrose molar mass has been prepared by dissolving 68.5 gram of sucrose in 1000 gram of water. So this is the weight of solute. Sucrose is the solute. So weight of solute is given, WB is given 68.5 gram. The molecular weight of the solute MB already given 342 gram per mole. Where it is dissolving 1000 gram water. So weight of solvent also given 1000 gram of water. The freezing point of the solution TF, freezing point of the solution supposed to calculate, and KF value, the cryoscopic constant KF value is already given 1.86 Kelvin kilogram mole inverse. You know what is a simple equation to calculate depression in freezing point? We have the equation delta TF is equal to KF into molality. What is mean by delta TF? TF naught minus TF equal to KF into. What is molality? WB by MB into 1000 divided by WA. Correct. What do you have to calculate? TF. What is TF naught here? Freezing point of pure solvent. What is the pure solvent? Your solvent is water. What is the freezing point of water? 0 degrees Celsius, right? 0 degrees Celsius. No need to convert it to Kelvin, okay? See, the options are also given in degrees Celsius. Minus TF. TF need to calculate. KF value already given 1.86. Weight of solute is given 68.5. Molecular mass of solute is given 342 into 1000 divided by weight of solvent is which one? 1000. Okay, cancel. You will get TF value approximately a negative value you are expecting. Your value will be minus 0.372 degrees Celsius will be the answer. Option A can be the answer. Option A will be the answer. Alright. Next question. We can go for the assertion reason question in section B. You know, assertion reason, A, B, C, D, all of you just pause the video and follow the rules, instructions, what you have. Let's go to question number 45 directly. Alright, question number 45. What is assertion? With hydrogen iodide, anisole gives iodobenzene and methanol. What is anisole? Anisole means benzene with OCH3, methoxybenzene. We know when we treated anisole with HI, you know, H plus is there, I minus is there, where we can break in an aromatic ether. When you're breaking the CO bond, the condition after the breaking, we should have phenoxide ion. You know, this is a CO bond, this is another CO bond. We should break here, then only we will get a phenoxide ion here, this carbon positive. To the phenoxide ion, what will attack? H plus will attack. We will get benzene with OH. To the CH3 plus, I minus will attack. We will get CH3I. Once again, all of you read assertion. With HI, anisole give iodobenzene and methanol. Are you getting iodobenzene? No, phenol and methyl iodide. This is wrong. Iodine is a good leaving group. Of course, right. Down the, in the halogen, which is the best leaving group, iodine. Because of bigger size, its electronegativity lesser, the bond will be weaker with other elements, so it can leave so fast. So iodine is the best leaving group. So assertion is correct, reason is which one? Wrong. Just opposite, right? Sorry, assertion is wrong, reason is correct. So what is the answer? Let's go with option D, right? Yes, option D for the first question. Assertion is false, reason is, I think reason is also false given here. Yes or no? Reason is also false given here. I think it should be reason is true. Okay, that's a condition. I'm just making a correction. Assertion is false, reason is true. That's the correct answer possible. Question number 46. Assertion. Fluorine exists only in -1 oxidation state. Yes or no? Fluorine is the topmost element. In the halogen family, fluorine cannot show variable oxidation state. You know the reason? Because it doesn't contain d orbital. So this is a correct statement. Fluorine is having 2s2 2p5 configuration. Yes, through that they are showing that it doesn't have any d orbital. Correct. That's the exact reason also. So let's go with option A. Option A. Next question. Question number 47. Symmetric and unsymmetric ether can be prepared by Williamson synthesis. You know, through Williamson synthesis, this is a symmetric ether. This is a unsymmetric ether. You can prepare any kind of ether through which one Williamson synthesis possible. Option assertion is correct. Williamson synthesis is an example of nucleophilic substitution reaction. Yes or no? Yes, correct one. But is it a reason? No. Is it a reason? No. Why? Because you're getting symmetric and unsymmetric ether. That's because of which reactant you consider, which haloalkane, which sodium alkoxide you consider. Depends on that, you will get the symmetric or unsymmetric ether. Correct? Alright? Then, so but that is not a exact reason. Okay? 48. So the answer is which one? Here it is B. Assertion. Oxygen is thermodynamically more stable than ozone. Yes. You know, oxygen having a double bond, it's more stable due to the stronger bond. But ozone is thermodynamically unstable, you know very well. Because ozone on decomposition, we will get O2, right? Ozone on decomposition, we will get O2 and nascent oxygen. This reaction is feasible one. Because the Gibbs energy in the reaction is negative. Gibbs energy negative in a reaction, always the reaction is feasible or spontaneous. So oxygen is stable, yes, ozone is unstable, correct. Then ozone decomposes to form oxygen. Yes, right. Ozone on decomposition we will get oxygen. That's also correct. But is it an exact reason? No, dear student. Why ozone is thermodynamically unstable mean their Gibbs energies are react the negative value. Gibbs reaction negative for a reaction is feasible or the reaction can happen, which means decomposition of ozone can be happen without any external thing. So that's not an exact reason, option B. 49. Assertion, orthonitrophenol is less soluble in water than meta and para isomer. Dear all of you know, this is called orthonitrophenol. In orthonitrophenol, you may studied hydrogen and oxygen can make a intramolecular hydrogen bonding, right? Intramolecular hydrogen bonding. You know, it is a weakest bond. In orthonitrophenol, the bond is a very weak intramolecular hydrogen bonding, whereas in meta and para isomer, they are showing very strong intermolecular force of attraction that is called intermolecular hydrogen bonding. Correct. So orthonitrophenol less soluble in water. Yes, orthonitrophenols are less soluble in water because they have a very weak intramolecular hydrogen bonding, whereas meta para contain very strong intermolecular hydrogen bonding. Okay. Then meta and para nitrophenol exist as associated molecule. Yes. This is why it is called intra. Intra mean within the molecule. Yes, you know, the hydrogen and oxygen are attacked in the molecule. But let me consider a para-nitrophenol. This is a phenol para position nitro group. Let me take one more phenol para position nitro group. Here you see, if you consider these two para-nitrophenol, here is the oxygen and hydrogen are connecting. This is in between two molecules, which means they are associated molecule. Associated means what? One para-nitrophenol, in one orthonitrophenol, a hydrogen bonding is possible because the hydrogen and oxygen, there is a weak hydrogen bonding. But if you consider the same one hydrogen and oxygen here, it is possible to make a bond within the system? No. So they need one more or para-nitrophenol. The same like meta. So in para-nitrophenol, two molecules are associated. Not two molecules, many are there. But if you want to make a hydrogen bonding, it is two molecules are necessary. So they are associated, combined form. So that is also a correct statement. But is it the exact reason? Why orthonitrophenol is less soluble in water? Because they are having very weak intramolecular hydrogen bonding. They cannot make a strong hydrogen bonding with the water. But para-nitrophenol can having which bonding? Intermolecular hydrogen bonding. That is a very strong hydrogen bonding. Alright. So this is not the exact reason, but both statements are correct. Let's go with option B. Next, I'm going to the last part, section C. Question number 50. Match the column 1 and column 2. Dear all of you, which halide is this? You know, here chlorine connected carbon is an sp3 carbon. This is sp2 carbon. This is sp2 carbon. Or you know, this is called what? Allyl group. This is a allyl chloride. This group is called what? Allyl. So allylic halide. So A is matching with S. I think that's enough to get the answer. A matching with S, only one answer. Anyway, let's go with others also. CH2 double bond CH. What is this group is called? Vinyl halide. Vinyl. This is B. B with the Q. CH3 CHCl Cl. You see both of the chlorine are on same carbon is called what? Geminal dihalide. This chlorine is on first carbon, this chlorine on second carbon. So chlorine on adjacent carbon is called what? Vicinal dihalide. So altogether answer is option C. Next one. Which of the following analog is as incorrect? Incorrect. Okay, incorrect. Dear student, what is the shape of XeF4? Square planar. Correct one. What is the shape of, XeF4? This is the shape of XeF4, square planar. What is XeO3? XeO3. Pyramid shape, trigonal pyramid shape. Correct one. Question is, which is incorrect. Not option A. Option B, XeOF4. XeOF4 structure, dear all, it is like this. A square a pyramid, square pyramid, and one lone pair is there. XeOF4 square pyramidal, correct one. XeF2, yes, linear. XeF2 linear with a 3 lone pair. That's also correct. So not option B. Option C, XeOF4, we already said XeOF4, is it pyramidal? No, it is actually square pyramidal. And XeF4 is square pyramidal. No, XeF4 is square planar. Option C is the wrong one. XeO3 pyramidal, XeOF4 square pyramidal. That's again correct. Next one. The number of S double bond O and SOH bond present in, so how many, which all bond? S double bond O bond and SOH bond present in peroxodisulfuric acid. What is peroxodisulfuric acid? H2S2O8 is A. And for pyrosulfuric acid, what is pyrosulfuric acid? Pyrosulfuric acid is H2S2O7. That's also called oleum. Dear all of you, let's calculate. Fine. Let me tell you once again what is the structure of H2S2O8. Remember, what is the structure? S double bond O, OH. S double bond O, OH. And there are 2 oxygen nearby. What about H2S2O7? Middle there is only 1 oxygen. That's it. S double bond O, OH. S double bond O, OH. Middle there is only 1 oxygen, right? This is the geometry. Now let us count how many S double bond O bond in first system. How many S double bond O bond? 1, 2, 3, 4. There are 4 S double bond O bonds. And how many SOH bond? 1, 2. So there are 2 SOH bond in first system. 4 and 2. Okay. What about S double bond bond in oleum H2S2O7 or pyrosulfuric acid? Again 1, 2, 3, 4. So S double bond O bonds are there 4. How many SOH bond? That's dear students, same one, right? 2 are there. So 4, 2, 4, 2. Answer is 4, 2, 4, 2. 4, 2, 4, 2. Answer is option D is the one. Alright, let's go to the last system. We have a case study question. All of you just pause the video and just read the topic once again. I think the question is related to the chapter solid state. Okay, hope you stop the video and read that carefully. I'm going to the question based on this paragraph. Question number 53. Which of the following statement is or are correct? Alright, option first one. Crystalline solids have definite characteristic geometrical shape. Correct? Crystalline solids having, because of long range order, a perfect geometry is there. Crystalline solids having long range order. Yes, in crystalline solid, throughout the system, the particles are arranged very proper manner. Sodium chloride and quartz glass are example of crystalline solid. Is it? Sodium chloride is a crystalline solid, okay. But quartz glass is a amorphous, right? Not that. It's a wrong statement. Crystalline solids are isotropic. No. Crystalline solids are which one? Anisotropic in nature. So only 1 and 2 statements are correct. Question number 54. Crystalline solids are anisotropic in nature. Correct one. What is the meaning of anisotropic? Option A. Irregular pattern of arrangement of particle which repeat itself periodically. No. What is meant by anisotropy? When you calculating the physical properties of the crystal, you are getting different values in different direction. Is it option B? Different values of some physical properties are shown when measured in different direction. Yes, that's a correct one. Question number last 55. Which of the following statement about amorphous solid is incorrect? Which of the following statement about amorphous solid is incorrect? They melt over a range. No. Crystalline solids having sharp melting point, amorphous solids having range of melting point. That's a correct statement. They are anisotropic. No, dear student. Question is related to which one? Amorphous solid. Amorphous solids are isotropic. They are not anisotropic. And what about there? There is no order arrangement. Amorphous solids having short range order. Correct one. They can be compressible. Right. So the answer for question number 55, we can say that option B from the chapter solid state. So dear all of you, hope you are preparing well for your upcoming term 1 examination. So wish you all the very best. Keep practicing so much question for your term 1 examination. Let's make more marks in term 1, even in term 2 also. So thank you all. All of you keep practicing. Whatever the doubts you have, anytime you can contact us. Thank you all. Bye.